Welcome back to the other questions of exercise 6.2. Okay, the question number 4. The question number 4 says the triangle ABC, D and EF are the points in such that DE is parallel to AC and DF is parallel to AE. DE is parallel to AC, that means the triangle ABC we have to consider, and DF is parallel to AE. DF is parallel to AE, that means ABE, the triangle we have to consider. Okay. So to prove, what we have to prove? BF upon FE, BF upon FE and BE upon EC, BE upon EC. So how do we do that? Let us see in the proof. In triangle ABC, DE is parallel to AC. DE is parallel to AC. That means by basic proportionality theorem, AD upon BD and BE upon EC. By Thales theorem, because DE is parallel to AC, that means D have divided this side and E have divided this side. So another one, in triangle ABE, since DF is parallel to AE, so again AD upon BD is equals to BF upon EF, FE in the triangle ABE. So this is the second result, which is again from the Thales theorem. Okay, now when we compare the two equations, we come up to the result that BF upon FE is equals to BE upon EC. BE upon EC. So this is our result what we need in the question. Okay. Now let us have the next question. Given a different kind of figure but a triangle only, PQR. Here O is the point where all the vertices are joined, E and F such a way on the PQ and PR that we have to show that EF is parallel to QR. It is given D is on the line PO where D and E, D and F are joined. In the question given, DE is parallel to OQ and DF is parallel to OR. Since DE is parallel to OQ, then this triangle we have to consider POQ, and DF is parallel to OR, that means POR triangle we have to consider. So to prove EF is parallel to QR, let us begin here. In triangle POQ, ED is parallel to OQ. ED is parallel to OQ. Then we have with the Thales theorem PE upon QE and PD upon OD. PE upon QE and PD upon OD. That is the first equation. And again in triangle POR, DF is parallel to OR. So PF upon RF and PD upon OD. PF upon RF and PD upon OD. This is again with the basic proportionality theorem only. And when we compare the two equations, we have the result PE upon QE, PF upon RF. PE upon QE and PF upon RF. Now you see the whole triangle PQR, EF and QR. By the converse of basic proportionality theorem, if the ratios are equal because of these points E and F, then the line because of those points will be parallel to the third side, that is EF is parallel to QR. So by the converse of basic proportionality theorem, we can say EF is parallel to QR. Okay. Now let us move to the next question. Here we again got a different figure, the triangle PQR. Okay. The point O is inside the triangle where all the vertices are joined to that point O, and the point A, B, C are on the line O, PO, QO and RO, such that AB is parallel to PQ, AB is parallel to PQ, AC is parallel to PR. We need to show BC is parallel to QR. How will you show? By following the same steps. Here, since AB is parallel to PQ, AB is parallel to PQ, so POQ is a triangle which we need to consider to have the Thales theorem. So in triangle POQ, OA upon PA, OB upon QB. With the same reason, BPT, OA upon PA, OB upon QB. Okay. Then again, AC is parallel to PR. It is given. So because of this, here OA upon PA and OC upon CR. So when we see these two equations, this and this, Here you see the left hand sides are equal. So obviously the right hand sides will be equal. That is OB upon QB and OC is OC upon RC. Now where we are getting this? OB upon QB and OC upon RC. So it is all happening in the triangle QOR. And because of the point B and C, the ratios are equal. So by the converse of basic proportionality theorem, we arrive at the result that BC is parallel to QR. Okay. So these are the solutions of few questions. The solution of the other questions we'll have in the next video. Thank you.